good morning, students. Good morning, students. Steps for constructing root locus. Continued. Okay, why? Because in the last session, so we have seen 6 steps. Okay, so if the step is what the branch on the root locus. So second thing is what a number of branches. The third step is what on the real axis a point will exist. So the fourth step is that root locus terminates at s equal to infinity. So for that we have calculated the asymptotes. So in the asymptotes, now how many number of asymptotes, what is the centroid value, and what is the angle of asymptotes and all we have discussed. The fifth number step is what root locus is always symmetrical with respect to the real axis. The sixth step is what a point on the intersection of two or more branches, that is a breakaway point. How to calculate breakaway point and all we have discussed in the last class. So today we will go for the step number 7. All of you make a note of this one. Step number 7. So in this particular step number 7, so here all of you can make a note of this one. Okay, the angle at which the angle at which the branch of root locus leaves leaves complex poles. See, this particular steps will be appearing only if the complex roots of poles are coming. So if complex pole is not coming, then this particular 7th step will not existing. Okay, so here the angle at which the branch of root locus leaves complex pole is called angle of departure. Is called, make a note of this one, angle of departure. Okay, so this particular angle of departure. So what do you mean by angle of departure? It is nothing but the angle at which the branch of root locus leaves the complex pole is called as what angle of departure. So now what is how to find this particular angle of departure? So you can write this one equation, the angle of departure is computed using angle of departure is computed using the formula. So what is the formula? So the formula is D. The phi indicates angle, D represent departure. Phi D is equal to 180 degrees minus summation of angle of all poles minus summation of angle of all zeros. So if the 4 poles are there, 2 zeros are there, what is the angle of each pole? That is 4 poles, you need to consider the summation angles with respect to the degrees minus summation of angle of all zeros. For example, if the 2 zeros are there, the 2 zeros also we need to consider. The angle of 2 0, one is 90 degree, another one is 30 degree, like that. So 90 plus 30 equal to 120 degrees. Okay, so that particular whatever the degree finally we will get. So that is called what phi d. That is angle of departure. Clear. So when the angle of departure is coming, there is another concept called what angle of arrival. Okay, this particular 2 steps are like a mirror image. So one step if you find out the angle of departure, angle of arrival will be the just opposite, that is symmetrical with respect to the real axis. So as per the steps concerned, we need to write this particular step, but while solving the numerical, you need not to calculate once again the angle of arrival. So just take the negative sign with respect to that particular or else symmetrical angle. Okay, with respect to the angle of departure, you will get the angle of arrival. So how you are going to do it, we will discuss in the numerical. So as for the steps concerned, you write down the definition. the angle at which a branch of root locus arrives at a complex 0. So at an angle of complex 0 is called angle of arrival. It's called angle of arrival. So angle of where the branch is leaving. So by you know that for a branch of a root locus will leave from the pole and end at the 0. So starting point will be at pole and ending point will be at 0. So that is why when you are talking about the departure, angle of departure, it will leave from the pole. When you are talking about the arrival, it will arrive at the 0. Okay. So the angle of arrival is computed using the formula So what is the formula? So we write that phi arrival is equal to 180 degrees minus, so we are taking in the reverse wave, summation of angle of phi z minus summation of angle of phi p. This pole. Okay, so poles and zeros we can able to write it here. Okay, so here I can see that the two equations, angle of arrival and angle of departure. So two equations, phi d equal to what? 180 degrees is common, 180 degrees minus. Here summation of pole minus summation of zeros. So when talking about the angle of arrival, 180 degrees minus angle of summation of zeros minus angle of summation of poles. That is the only the thing. So now this is very simple. This also will take another 1 or 2 minutes for you to do it. Okay. So those are the step number 7 and 8. Now if you just go for step number 9. Okay. So step number 9. So what is particular step number 9? So here the point of intersection we need to write down. Okay, we need to calculate the point of intersection of root locus on j omega axis and range of k for closed loop stability and range of k for closed loop stability are found by RH criteria. So now when we were solving the numericals in the RH criteria, we found that how to find out the point of intersection and how to find out the what do you call for that range of k for closed loop stability. So this can be found out by using the RH criteria. So if we don't want to solve it using RH criteria, there is an alternative method also. So what is that particular alternative method? See, we will be following the alternative method only. Okay, so we'll write that one. Please make a note of this one, all of you. And alternate technique is also given. So what is that particular alternative technique? Put S equal to j omega. So in the explain, so whatever in the characteristic equation S is there, so you replace the S by j omega in the characteristic equation. So once you put S equal to j omega in the characteristic equation, very simple, separate separate out the real and imaginary parts. Separate out real and imaginary parts and equate them to 0 and equate them to 0. So once you separate the imaginary part and the real part, equate them to 0. That means what? The real part equate them to 0 and imaginary part equate them to 0. And solve this equation. Solve this equation for values of k and omega. So once you equate these particular equations, to 0, so you will get two equations in your hand. So solve these two equations in order to find the k and omega. So here omega means j omega, the point of intersection you are going to get, and k means what? Range of k you are going to get. So these are the 9 steps for plotting the root locus. Is it clear to you? So just go through it. So these are the 9 steps in order to plot the root locus. Is it clear to you? So now we will see the numerical. Okay, first we will see the numerical. So once you are seeing the numerical, so you will come to know how to draw the numerical, how to plot the root locus for a numerical. So then you will understand in a better way. Okay. So now we will go for the numerical. So write down the first numerical. So in that particular thing, write the question, all of you. A negative feedback control system, FBCS, indicates feedback control system as an open loop, transfer function, that is TF. I made it as short, TF. So what is the transfer function they have given? They have given that G of S into H of S equal to K divided by S into S plus 2 into S plus 5. So where K must be greater than or equal to 0. Okay. So sketch the root locus. Plot for the values of k. From 0 to infinity. Comment on the stability of the system, or comment on the system stability. Okay. So this is the question they have given. So you can able to understand one thing, that in that particular, like this only they will be giving the question. So maybe the G of S and H of S equal to the values they given, no? So that particular value may change. But apart from that particular thing, so most of the things will be very, very similar. Okay, 90% of the numericals are very, very same. So you can just do like that. What do you call for that? You can just take the numerical and keep on solving. Okay, you will arrive at the answer. So here they asked that they have given the transfer function. They asked us to plot the root locus. We will plot it by using the 9 steps. And for the values of k and 0 to infinity, so comment on the stability. So that part also we are going to do it. Okay. So once you have taken this particular thing, so write the solution. So in the solution, step number 1. So what is the first step? So plot poles and zeros. On S-plane. Plot poles and zeros on S-plane. That's the first step. Okay. So when we are plotting the poles and zeros on the S-plane, we will draw the S-plane first. Okay. So we will draw the S-plane. So we will draw it. Okay. So we can say that it is the x-axis is sigma and y-axis is what, j omega. So it is a negative sigma and in the bottom it is negative j omega. So correct. So this is the thing. Now when you are talking about this one, so there are three things to be considered. Okay, so what are the three things to be considered? Poles are there, three poles are there. Okay, so what are the poles? S equal to 0 is one pole, S equal to -2 is another pole, and S equal to -5 is another pole. Why? Because in the denominator we can be able to see that, okay, in the denominator we can able to see that three poles are there. One S into S plus 2 into S plus 5. If you take that particular root of it, one will be S equal to 0, another will be S equal to -2, another one will be S equal to -5. And there are no zeros in the numerator. Numerator is not having any S term. That means what? Zeros are. So I can say that number of poles equal to what? 3. Number of zeros equal to what? 0. Clear. So now I can say I will mark it, okay, randomly or approximately I will mark it. So 0 means what? In the center point. So I can say that S equal to 0. And approximately I will make it S equal to -2. So if it is 2, 2, 2, 4 and 5 is this one somewhere here. So I can make it S equal to -5. Okay, after we marking this one. Okay, after we marking this one. So we know that. So at pole, K value will be equal to what? 0. At pole, K value will be equal to what? 0. At pole, K value will be equal to what? 0. So that particular K value also we need to write it down. Clear? So this is the first step. Okay, so this particular plane is called as what? S plane we say. So I can say that this is the S plane. So here in the x-axis we have taken the sigma and in the y-axis we have taken the j omega. Okay, so here S plane is what? S plus or minus j omega is the term we can consider. S plus or minus j omega is the term. Is it clear to you? This is the first step. So once we have done with the first step number 1, okay, so we can go for the step number 2. So I can make a note of this one. Step number 2. So in the step number 2, so we know that, okay, so when k equal to 0, points are on poles, they are S equal to 0, -2, -5. S equal to 0, -2, -5. But we know that every branch will start from the pole and ends at the zeros. So here only poles are there. There are no zeros. When there are no zeros, I can say that they will be at infinity. Once nothing is there, once they are traveling, where they will end? They will end at the infinity. So that is what the simple sense here. So I can say that a branch. Okay. So when k equal to 0, points are on poles, s equal to 0, -2, -5. So similarly, I can say that when k equal to infinity, okay, so 0 to infinity we need to consider points are on zeros. Since zeros are not there, okay, so s will be ending at infinity, infinity and infinity. Okay, so now this particular infinity value is not given anywhere, but we will be assuming that for every pole there should be a 0, because pole once it is starting the branch should end at infinity. Somewhere it has to stop. That is why I can say that for every pole there should be a matching 0. We don't know. Okay, so which one is matching which one? So, but in this particular scenario, there are no zeros. So, we consider all three as infinity only. Clear? That is how it is going to work. This is the step number 2. This is step number 2. So, I can say that for every pole, there should be a 0. That is also one of the understanding you can make it. So, now the step number 3 when you are going. So, I can say that step number 3. So, here in the step number 3, I can say that a branch of root locus always starts on a pole, that is k equal to 0 and ends on zeros, that is k equal to infinity. So this is the step number 3. Clear? So this is the indication. So after we understanding this particular 3 step, we'll go for the 4th step. Okay. So I can say that step number 4. So what is step number 4 is saying? It is saying that, okay, so we need to find out the number of branches. So number of branches of root locus, number of branches of root locus. So here that is equal to what? P or Z I said. Okay. So whichever is greater. Whichever is greater. So here P equal to what? 3 and Z equal to what? 0. So P is greater than Z. So I can say that the number of branches will be equal to what? 3. Okay. So therefore, so number of branches will be equal to what? 3. So I think this is very, very simple. You can understand very easily. The number of branches, that is equal to 3. So when you're talking about the step number 5, okay. So a point on real axis will lie on root locus, if number of poles plus zeros equal to odd number, So to the right of point considered, okay, point on the real axis will lie on the root locus. So if number of poles and plus number of zeros equal to odd number. So here number of poles and zeros, if you take it, so here pole is 0, pole is 3 and 0 is 0. So 3 plus 0 is 3. 3 is the odd number. So there will be a point will be lying on the right side. So what is that particular point? We will see. Okay. So here after writing this one, I write that one. In this case, poles plus zeros equal to 3. It implies there exists a point on real axis. And will lie on root locus. So this is the thing, step number 5. So a point on the real axis will lie on the root locus if number of poles plus 0 equal to odd number. So in this particular case, poles plus 0 equal to 3. So it implies there exists a point on the real axis and this will lie on the root locus as well. Okay. So this is the step number 5. So when you're talking about the step number 6, we'll go for the step number 6. So step number 6 is what? Regarding the asymptotes. Okay. So what is that particular asymptote is saying? First we need to calculate the number of asymptotes. Okay. So we can write this one, number of asymptotes is equal to P minus Z. Number of is equal to what? P minus Z. So what is that particular P minus Z? 3 minus 0, that is equal to 3. So it says that, okay, so it says that number of asymptotes equal to 3. There will be 3 points which are there. Okay, so I can say that there are 3 finite poles. So now number of asymptotes equal to 3 we have found out. The next step in the asymptotes is what? Finding the centroid. So how to find the centroid? So centroid will be equal to sigma A. So sigma stands for what in the real axis? A stands for what? Asymptote. Centroid sigma A will be equal to summation of finite poles minus summation of finite zeros. Summation of finite poles and summation of minus summation of finite zeros divided by P minus Z. Divided by P minus Z. So now here you can see that summation of finite pole. That means what? 0 is one pole. So plus of, okay, 0 is one pole. Okay, so plus of minus 2 is another pole. So plus of minus 5 is another pole. So minus summation of finite zeros are 0 divided by 3. So in this case, so 0 minus 2 minus 5 is it will be minus 7 divided by 3. Correct. Minus 7 divided by 3. So minus 7 divided by 3, if you find out, it will be coming like a minus 2.33. So minus 2.33 will be coming to you. Okay. So that is the value of center. That means what? On the left of the S plane. Okay. On the real axis, that is minus 2.33, we are going to get it. So that is the first thing. That is second thing, that is centroid. Okay. So now after finding the number of asymptotes as well as centroid, so we need to calculate angle of asymptotes. So we need to find out angle of asymptotes. So when you are finding the angle of asymptotes, it is the phi A. So that is equal to what? 2q plus 1 into 180 degrees divided by P minus Z. So where q will be equal to what? 0, 1, 2. So see here number of asymptotes are what? How many number? 3. So that is why the q value will be taken up to only 3. That is up to 2. That means what? 0 is for 1, then 1 is for second one, and second is 2 is for third one. That means what? 3 asymptotes. Okay. So here you can make a comment for the first numerical. So I can say that the ranges for number of asymptotes. Ranges for number of asymptotes. It is 0, 1, 2. Okay. So now first asymptote, if you are finding out the phi A, okay, so I can say that that is equal to, so if you just substitute the value, that is 2 into 0 plus 1, okay, into 180 degrees divided by 3 minus 0. So that will be called as what? 2 plus 1 is 3. So 3 into 180 degree. Okay, 3 into 180 degree. Not 3 into 180 degree, it is 0. Okay, so 0 means what? 0 plus 1 is 1. So I can say that 1. Okay, 1 into 180 degrees divided by 3. So 18 by 3 is 6. Okay, 60 degrees. So phi A will be equal to what? 60 degrees. So first one. So when q equal to, I can say that when q equal to 0, when q equal to 0, the phi A is equal to what? 60 degree. So next thing is what? Phi A. So that is equal to, we'll take q equal to 1. So in that case, 2 into 1 plus 1 divided by 3 into 180 degrees. So that is equal to 180 degrees only it will come. Why? Because 3 divided by 3 will get cancelled. So we will be left out with 3 into 180 divided by 3. 3 get cancels, 180 degrees obtaining when q equal to what? 1. When q equal to 1, I can say that phi A will be equal to 180 degrees. Okay. Similarly, when you calculate the next thing, so I can say that phi A. So 3 asymptotes we need to calculate. So I can say that here in this particular scenario, when q equal to 2, that means what? 2 into 2 plus 1, okay, into 180 degrees divided by 3 equal to what? 2 into 2 is 4. 4 plus 1 is 5. 5 into 180 degrees divided by 3. So I can say that 3 ones are and 3 60s are. So 60 degrees into 5 is 60 into 5 is 300. Okay. So 300 degrees. So that is when Q equal to what? 2. So now I can say that three angles we have found. One is what 60 degree, another one is what 180 degree, and the third one is what 300 degrees. So three angles of asymptotes we have found out. Is it clear to you? So now after we finding this particular number of asymptotes and all, so we can go for the next thing. That is step number 7. So after step number 6, we can go for step number 7. Okay. So I just write this particular step number 7. So what is step number 7 is saying? It is saying that a root locus is always symmetrical. Root locus is always symmetrical with respect to the real axis. A root locus is always symmetrical with respect to real axis. So this particular thing we will be observing in the root locus. Okay, this is step number 7. So now we'll go for the step number 8. So we can write this one, step 8 equal to, step 8 is saying that to find the breakaway point. So when we find the breakaway point, so how to find the breakaway point? I told you that dk divided by ds. So in order to find the dk divided by ds, we need to calculate. That means what differentiation of k with respect to s, and we have to equate that to 0. In order to obtain the dk divided by ds, we need to have the dk first. So k equal to what? So we have to go for the system characteristic equation. Write down the system characteristic equation. System characteristic equation is so 1 plus g of s into h of s equal to 0. So here 1 plus g of s into h of s is equal to what? K divided by s into s plus 1 into s plus 2. That is equal to 0. So if you just simplify it, you will get like a s cube plus 7s square plus 10s plus k equal to 0. So now obviously when you find this particular value, okay, so we can take the k value. So therefore I can say that k will be equal to minus s cube minus 7s square minus 10s. Okay, so this is the value you are going to get. So once you get this particular value of k, so we can able to differentiate the value of k. Correct. So if you want to differentiate the value of k, so now I can write one statement. So here I can say that the breakaway points are computed by using the formula dk divided by ds equal to what? 0. Clear. So once you differentiate the k with respect to s, so what is the thing? Dk divided by ds will be equal to what? If you differentiate, okay, I'll take this one. Okay, so minus is as it is. S cube, if you differentiate, it will become what? 3s square minus 7s square is, if you differentiate, it will become 14s, I guess. So later or minus 10 it will come. Okay, and that should be equal to what? 0. So I can say that therefore 3s square plus 14es plus 10 equal to 0. Because negative sign, I can take it common and I can shift it to other side. So you will get 3s square plus 14s plus 10 equal to what? 0. You are going to get it. Okay. So once we get this particular value of the equation, okay. So quadratic equation, even if you get it, the roots of the equation will find out. So roots of the above equation are computed by using formula. Okay, by using the formula, so that is the minus b, that formula is there. So or else by using the formula or through calculator. So by using the calculator, when you get the answer, you'll get like s equal to what? Minus 0.8 and s equal to what? Minus 3.78. So this is these two values you are going to get. Okay, you can make a note of this one and you can able to check it also. Yes, please tell me. Sir?
Yes, sir.
Sir, you want to ask anything, sir?
Actually, sir, this topic is control system, sir. Control system.
Yes, sir. Control system root locus I am doing,
Okay,
sir. I am just solving the numerical.
Right, mistake I have entered. Can
Sir, I am
continue,
not
sir.
hearing
No
your
issue, sir.
voice,
No.
sir.
It is audible to you, sir.
Yes, sir. I am audible, sir. You are
Sir, you
audible, sir.
complete your class. You can talk, sir. No issue. You complete your class, sir. No issue. No issue.
Yeah.
Okay. Sir?
Okay, sir. Okay, no problem. No problem. Okay.
Sir,
So the roots of the above equation are computed by using the formula. So s equal to minus 0.8 and s equal to what? Minus 3.78 value we are going to get. So all of you can please check it out. Okay, if you get, I think in calculator we will get the same answer. So now after you getting this particular values, right? So s equal to minus 0.8 and s equal to minus 3.78, we need to substitute these particular values of s equal to minus 0.8 and s equal to minus 3.78 in the k equation. You can just see this particular k equation what we got. So that is equal to what? K equal to minus s cube minus 7s square minus 10s. So in this particular equation, you need to put the s value. So now if you just put the values of s here, okay, so you'll get the k value. So when the k is equal to 0.8, if you minus 0.8, if you substitute, so what I got is 4.032. Okay, 4.032, that is the first thing, first value I got. And similarly, if I just replace, okay, so s value by s equal to what? Minus 3.78. Okay, so what I'll get is minus 8.2. Okay, so now two k values we got. Okay, so all of you can check it. If you get any other different value, you please let me know. So there is a condition called as what? K must be greater than or equal to 0. In order to satisfy this particular equation, k must be greater than or equal to 0. So we consider that positive value, that is 4.032, is holding correct, and this particular minus 8.2 should be ignored. So once we ignore this particular value, this particular s equal to what? Minus 3.78, the root value also should be ignored. Okay, this also should be ignored. Clear? So that is what exactly the concept here. Clear? So any doubt in this particular topic now? You can tell students. No, very good. So now after this one, I can make one statement. What is the statement? The value. So this is very important. Since it's the first numerical, you must learn everything, okay, in detail. So later you can understand in a better way. So the value of k at the break away point, BAP, the simple terms, BAP, should be, okay, should be real and positive, should be real and positive. So hence in the present, hence in the present context or present numerical or present problem, so there is only one breakaway point given by s equal to minus 0.8, given by s equal to what? Minus 0.8. Okay. So now if I just so there is another one step, step number 9, and later we have to solve that particular we have to plot that particular root locus. So that we will take care in the next class, because 12:50 we need to end the class, 12:42 or 43 now. So if I just recall the things what I have been discussed today, so we can go through this particular numerical. Okay, so from the beginning I just go through it. So if you get any doubt, you please ask me. So what is the particular, what is the given the numerical? The given numerical is what? A negative feedback control system as open loop transfer function, g of s into h of s they have given. So after that they asked us find the stability of the system and find the range of the values of k. So step 1 when we are talking about, step 1 is saying that plot the poles and zeros. Since the pole value is equal to what? S equal to 0, s equal to minus 2 and s equal to minus 5. So that particular things we have plotted here. So at pole k equal to 0, that already we know it. In the step 2 we have written that when k equal to 0, the points are on poles, that is s equal to 0, minus 2, minus 5. So when k equal to infinity, points are on the 0, that is s equal to infinity, infinity, infinity. Because there is no 0 which is given, obviously a branch of the root locus which is starting from the root pole will definitely terminate at the infinity. That's the thing. So next in step number 3, we say that a branch of the root locus always start on the pole and ends on the 0. That is a well-known fact. So in the step number 4, we say that number of branches. So in the number of branches, we say that P or Z. P or Z means whichever is greater. So in that particular context, I can say that P is greater than Z, that is 3 is greater than 0. We say that 3 branches are there. So after that, in the 5th point, we say that on the real axis, one point will exist. So you can say that breakaway point is already existing on the right side of the root locus. When you are plotting, we'll see that one. So on the step number 6, we can say that number of asymptotes. So number of asymptotes is P minus Z. 3 asymptotes will come. So for that centroid, we have found out centroid equal to what? The formula summation of finite poles minus summation of finite zeros divided by P minus Z. So we got the value minus 2.33. So next, later we have found out asymptotes. As in they are talking about asymptotes, we have found out phi A. That is 3 asymptotes. 3 angle will come. One is coming 60 degree, another one is 180 degree, another one is what? 300 degrees. So step number 7, when you're talking about a real root locus is always symmetrical with respect to the real axis. So that we have to observe when the root locus is being drawn. So next is what step number 8, in that particular thing, breakaway point we are going to find out, that is dk divided by ds equal to 0 we need to find out. So in order to find the dk divided by, that means for differentiation of k with respect to s, we need to have the k first. So in order to get the k, we need to take the system characteristic equation, that is 1 plus g of s into h of s equal to 0. So from that k value we have found, that is a minus s cube minus 7s square minus 10s. Okay. So later we have to differentiate, when you differentiate k with respect to s, we will get that minus 3s square minus 14s minus 10 equal to 0. So take the minus common sign and you shift to other side, you will get that 3s square plus 14s plus 10 equal to 0. So later the roots of the above equation can be computed by using the formula or calculator. We will use the calculator because formula is once again a tedious job and it is not required for numerical also. S equal to what? Minus 0.8 and minus 3.78. So now whether we need to consider both or not, that is the question. So in order to understand this one, you substitute the value of s in the k equation. So once you substitute the s equal to the value of s in the k equation, you will get the k value. So we have to see that the condition k must be greater than or equal to 0. So here minus 0.2 minus 8.2 will coming for s equal to minus 3.7, that you have to ignore. And when s equal to minus 0.8, we get the value 4.032, that is the accepted value. So okay, so we'll write the last statement, that is the value of k at the breakaway point should be real and positive. Hence in the present context, there is only one breakaway point which is given by s equal to 0.8. So that is what exactly the understanding for today. So do you have any doubt in this particular